but my hope will never die. But my hope will never die.
Hello, this is Diego Pinzon, and this is part A for XFLR5 final projects for Fundys of Arrow. If you stick for longer, you're gonna see part B as well. There's gonna be both part A and part B, because unfortunately I have to do both parts. Let's get started. First, we're gonna go to Module, Direct Foil Design. We're gonna click on Foil, and we're gonna click on NACA foils. We're gonna enter the digits of 2, 4, 15. Number of panels is good to leave like that. Alright, okay, so there we go. We got our foil, NACA foil right here. So next we're gonna go to Module, X Direct Analysis, and then here we're gonna click Analysis, Define Analysis, and then first things first, we're gonna make sure it's type 1, and in here we're gonna put the Reynolds number that we calculated, and it should be in the range of, we're gonna do this multiple times too, we don't run into any problems later on. So we're just gonna start with the one that we calculated, which is around 3,383,977. Alright, everything should be good. Alright, okay, and then we're just gonna do that a couple times. Type 1, we're gonna go from 3,200,000. Okay. We're gonna increment with increments of 100,000. So this one's gonna be 300,000, 3,300,000. All right, we're gonna do this again for last time. This time we're gonna put 300,400. 400,000. And of course I'm gonna add the exact Reynolds number that the software is calculated for, or it calculates itself, since I already did this. Alright, next we're going to go to here, all the way to the right, look at our analysis settings, make sure it's on alpha, which is angle of attack. We click sequence. It's going to have different numbers, but you want to make sure it starts at -5 and want to end at 15 degrees, and then we want it to increment by 1. So we just click analyze. We didn't see a bad pop-up, so we should be good with this part right now. Next, we're gonna go to our module. We're in plane design. We're gonna click plane, define a new plane. We're gonna do, this is gonna be the AR aspect ratio 10. Alright, we wanna click off the elevator and fin, and we wanna define the main wing. Of course, Y. So this is going to be the beginning, and this is the tip. So the chord length is going to be 1 for all of them. We don't want no offset, because it's going to be the rectangle wing. We want to make sure we have our NACA 2415 for both selected. All right. So, and then for Y, for the tips, we're gonna click 5, since we calculated it with an aspect ratio of 10. Your length is 10 meters, but here in this software it does it symmetrically, so you're gonna put 5 because it goes 5 on one side and 5 on the other. So that's right there, 10 meters long. Should be good. Alright, we're good on this one. We're gonna click save. Now next thing is we're gonna click on analysis, define analysis. We're gonna make sure that yep, type 1 is selected. Speed, we wanna do this at a speed of 50 meters per second, and yep, 50 meters per second. Analysis type, make sure that LLT is selected. Alright, type 1, click save, and we're gonna go here, make sure again that the analysis settings, it's set to sequence, and it starts from -5 degrees all the way to 15 in increments of 1. And all we have to do is just click analyze. Alright, perfect. So right here we have it. Right here is where we look at our graphs. It automatically shows us what we need to find. So here are the plots of the CL versus angle of attack. Here is CL over CD versus angle of attack. Here is CD versus angle of attack. And next thing is we want to go is come up here and to the OP point view. And next what we want to do is we just want to look at the 5-degree angle of attack information. So what we're gonna do is we're gonna right click on the graph and click show current OP point only, which will only give us the 5 angle of attack. Yeah. So and then next we wanna plot the local lift coefficients, induced angle of attack, and induced drag coefficient along the span. So what we're gonna do is right click again, go to current graph, define graph settings, and in here is where we change all of our variables to go look for what we want to find. So first things first is we want to plot the variation of local lift coefficient, which is local lift coefficient. Okay, here we have it. We're gonna go again, current graph, define graph settings. Then we're gonna go to induced angle of attack. Induced angle of attack. Alright, here it is. Once again, right click, define graph settings. And lastly but not least is we're gonna click and look at the induced drag coefficient along the wingspan. Click OK, and here we have it. So there you go. That's how you do the geometry, plot these graphs, and also plot the graphs of the 5-degree angle of attack along the wingspan. Thank you for our stick. Next is part B. Alright, so now is gonna be part B of the video for the final project. You thought I was joking when I told you that I was gonna do both parts, and I also thought I was joking too, but unfortunately I'm not. Anyways, let's get started. We'll first click onto module direct foil design and click foil, then knock of foils. We want, once again, of course, a 2415. That one already was there, but yeah, we want that airfoil. Click OK. Okay. Alright, that's our foil. We like our foil. Next, we go to module. We gotta click into XFLR direct design. Now, what we want to do here is click on analysis, define analysis, make sure type 1 is selected, and then we want to change the Reynolds number. Since it is a taper wing, the Reynolds number is going to change throughout the wing due to like the wing changes its chord length from the beginning of the wing to the tip of the wing. So yeah, the Reynolds number is going to change, so we have to calculate. Basically, we have to do this a bunch of times. We have to calculate. Starting again. Jesus Christ. Boom, boom, boom. All right. So we're here on we want to make sure that starting again. Try 3. Make sure get this right. Boom. Now we want to make sure that type 1 is selected. Next, we want to change our Reynolds number since it's a taper wing. The wing or the chord length is going to change all the way from the beginning to the wing to the tip of the wing. So that means that the Reynolds number is going to change. And in order to account for that, we have to do a bunch of these. We're going to start with our calculated Reynolds number at the tip, which is around 600,000. 3. All right. Click OK. And we're just going to keep doing that a bunch of times. And we're going to be incrementing with 100,000 for the Reynolds number all the way until we get to 800,000. Alright, so after we go one by one, make sure we put every single Reynolds number from 600,000 all the way to 4 million. We want to click on Analyze on all of them. Make sure that all of them are analyzed. Should be all analyzed already. Yep. Yeah, I just want to make sure that all of them are analyzed. Click one by one. Just go down the line, and once we have that, we're done with this part. We want to go to module, wing and plane design. Next thing is we want to click our plane and define new plane. This is what we're gonna have to do to define our wing. So this is the wing with taper ratio of 0.6. So we're just gonna call this TR 0.6. We want to click off of elevator and fan and click define on our main wing. So we want to make sure the foils are both set to NACA or NACA 2415. Next, we want to make sure that the beginning of our chord length is 1. Our tip, the chord length is going to be 0.6. Our Y, so our whole wing is going to be 8 meters long, but we're going to put 4 here because it's symmetrical and it's going to go 4 on one side and 4 on the other. So in total it's going to be 8 meters long. We want to make sure our offset is 0, and that should be our tapered wing. So we click save. Click save again. There you go, we have our tapered wing right here. I'll change the color real quick to blue. Next, we want to click on Analyze, Define, and Defining Analysis. Make sure that Type 1 is selected. This is going to have velocity 10, but we want to change it to 50. And Analysis, make sure that it is on LLT. Click Save. And go to the right side. Make sure that the is set on Analysis setting is set on Sequence. And the angle of attack starts at -5 degrees all the way to 15 degrees, and it increments by 1 degree. So click Analyze. I'm going to show you real quick how it looks, all of the points. So that's our taper wing. So next is to show you how we get our plots. So to get our plots for our CL versus angle of attack, CL over CD versus angle of attack, and CD versus angle of attack, you want to go all the way here and click on this polar view module, and it should right there, it should just essentially give you, or it should just pop up right there, your graphs, the ones that you need. If you have different variables, what you're gonna do is right click on the graph, go to current graph, go to define graph settings, and change the variables right here. Our x-axis could be angle of attack, all of these, and our y-axis we can change it to CL, CD, right here CL over CD versus angle of attack, and so on. Next is to look at our angle at 5-degree angle of attack. We want to look at the local lift coefficient, the induced angle of attack, and induced drag coefficient along the wingspan. So to see those plots, we're gonna go back to OP point view, and we're gonna right click on the graph again and click on show current OP point only. We're gonna click on the 5-degree angle of attack, and next we're gonna right click again on the graph, click on current graph, define graph settings. Now right here it's already on induced drag coefficient, as you can see. Now we want to look at our local lift coefficient. So we go local lift coefficient, look at the variable, find it, click OK. Here is our local lift coefficient. Next, right click again, define graph settings. We go and look for induced angle of attack, click OK, and right here is our induced angle of attack. And once again, you already saw the induced drag coefficient. So just right click at the graph again, click graph settings, and we do right here, we just find induced drag coefficient. Click OK, and there we have it. That is our video on how to do the geometry, plot the CL versus angle of attack, CL, CD versus angle of attack, CD versus angle of attack, and plot all the graphs that we need at the 5 degrees angle of attack along the wingspan for both part A and part B. Thank you.